So this is a relatively quick video that introduces the concept of flood occurrence, of flood recurrence, excuse me, and a little bit more about flooding and how what the 100-year flood means. Um, During an earlier part of the class, and in this unit on rainfall and runoff, the concept of a levee was introduced, a natural levee, and then how those natural levees are fortified to to hold back more water. And basically, what happens when you do that, a natural levee might be designed by nature, so to speak, to allow the creek to overflow and flood out into the floodplain once a year or once every couple of years, something like that, kind of very frequent interval. Um, as we have gone into areas where the floodplain is, like this map is showing, we like to live in the floodplain. We like to farm the floodplain, and we don't like it to flood. So what we do is build up levees instead of being a few feet tall to 15 or 20 feet tall. And what that does is cause the river to flood not every year or every other year, but much less frequently, theoretically. It will still flood. They'll just be bigger floods, basically. And this map shows the Sacramento Valley as being levied up quite a bit here, as you can see, hundreds and hundreds of miles of dirt levees. And when we get into the Delta section, we're going to talk more about those levees and how they work and um, problems that might occur with them. Um, what I want to do for this talk, though, is to get specifically into the concept of flood recurrence intervals, the 100-year flood, and all that. This is a map of Sacramento County showing the 100-year FEMA, Federal Emergency Management Act, floodplain. And all the colors here these are the A and AE and AH. All that is, there are nuances here, but basically, this map shows if it's got a color, it's in the 100-year floodplain, except for yellow is incorporated, where you don't see the floodplain where there's a city. Dark blue is a body of water. So zooming out here in Sacramento County, all these lightish blue areas are floodplain. These green areas also are 100-year floodplain. And this is why I want to talk about what the 100-year floodplain means, how it's calculated, and some interesting things about it, because it really is important to understand if you're anywhere near the 100-year floodplain. For whatever reason, if it's an incorporated area, here's Folsom, here's Sacramento, it's yellow. They don't show you where within the incorporated areas is part of the 100-year floodplain. Frankly, I'm not sure why. I know that there are areas within incorporated areas that are within the 100-year floodplain. The FEMA maps don't show it. But, for the more undeveloped areas, the Consumnes River areas, here's Galt, you can see that the 100-year floodplain pretty much follows the geography of the river network. So, and I don't think there's a lot of levees on these river systems. So it's kind of intuitive that, this is the 100-year flood area kind of is near where there's major rivers. So what I want to do, though, is again focus on what is this 100-year floodplain and what does it mean. And I've got a formula here because you know how I like formulas, but I'm not, for this description in this topic, I'm not asking you to use this formula and do practice problems. I do want you, however, to be aware of what the 100-year floodplain means and how it's calculated. So, and to introduce some terms. The key term is the recurrence interval. So that is sort of an intuitive term. It means how frequent does this event occur. So the recurrence interval for the 100-year flood is once every 100 years. And so the probability of a chance, that is a chance of a flood, the 100-year flood in any year, is the inverse of the recurrence interval. So if the recurrence interval is 100 years, the chance of that happening in any given year is 1 over 100, or 1%. So you'll hear that, hey, in any given year, there's a 1% chance that you will get a 100-year flood event. This chart hopefully kind of drives this home. If the recurrence interval is 100 years, that is once every 100 years, it's 1 in 100, that's a 1% chance. 1 over 100 is 0.01 or 1%. This second year, if it occurs every 2 years, then the chance of it happening is 1 in 2, which is 0.5 or 50%. So that's the terminology. And I'm going to dive in a little bit deeper just to kind of provide that more in-depth look here in a minute. But before that, I want to lay out a key concept. One is the rules of probability that, if a 100-year event happens in 2020, goodness knows why not 2020, everything else is happening this year. That doesn't mean that in 2021, that doesn't mean we won't have another 100-year flood for 100 years. It just means every year there's a 1% chance that will happen. So if it floods, if we have a 100-year event in 2020, that in 2021, the chance of that happening is the same, 1%. The other thing, and I don't know if you've had statistics class or had some statistics and completely blocked it out of your mind, but when you look at the chance of a 100-year event happening over a period of a long time, it changes. So it's called cumulative probability. So actually, and it follows this formula. So let's say you want to know over a period of 30 years, what's the chance of a 100-year event happening? Because it's 1% each year, fine, but over 30 years, it's more than 1% chance over a period of 30 years it's going to happen. And this is the formula for it. You want to know the probability of a 1% chance in 30 years. It looks like this. It ends up being, there's a 26% chance that in 30 years, a 100-year event will happen. I might not be making this more clear, but check out these words. And the reason that's important, it goes into calculations of flood insurance rates and mortgages, because they figure you're going to live in a house, if you're lucky, for 30 years. And so they want to know, hey, I know that every year there's a 1% chance this place is going to flood. But if you live there for 30 years, what's the cumulative combined chance over that whole period of time that you might experience a 100-year event? It ends up being a 26% chance. So that's kind of interesting. So those are the two kind of misconceptions. One, even if you have a 100-year flood event in 1 year, the next year, your chances are still the same, 1% every year. And if you're in the same place for a long time, that chance keeps getting more and more and more that it's going to happen. So I want to go in just a little bit deeper, like I say, how the recurrence interval is actually calculated, because it's kind of interesting. And they use this formula. The recurrence interval is the number of years that you have on record for that river divided by the rank of that event. And I want to give this a try here. So here's what it looks like. Here's a table of, let's say you've been monitoring a river for 100 years. That's awesome. You have 100 years of record. And what you do is take each peak discharge for each year. Every year has one highest discharge, right? Write it down, and then you rank them. It doesn't matter which year it occurred. you just rank it. In this data set, the number one flood event happened to occur, sorry, let me center this, in the year 1892, where that river did 1,000 cubic feet per second as a peak discharge. The second highest flow ever recorded in 100 years. Doesn't matter that it was 1953 or whatever, it was 976. So you take 100 years of peak discharge and you rank them from 1 to 100. So the lowest discharge ever happens to be 15 cubic feet per second. So that is the ranking. Each year, each peak discharge gets a rank. And so the recurrence interval is the number of years on record divided by the rank. So a 100-year flood event, that's the number one ranked event. That is the highest event in 100 years. So the calculation looks like this. The recurrence interval is 100 years on record plus 1 divided by the rank of that event, number 1, is 101. Okay, that's its recurrence interval is every 101 years. It's the 1 is there for statistical purposes, let's say. The chance then of this event happening is 1 over 101, 0.099 or 1%. The lowest ranked event, number 100 here, this is the lowest flow ever recorded in those 100 years. What's the chance of that event happening? Well, then the number of events, the number of measurements is still the same. N is 100, so it's 101 divided by the ranking. The ranking is 100. So that's basically 1. So the chance of it's happening is 1 divided by 1, or 100%. So that, again, I'm not going to ask you to calculate these. I just want to give you an understanding of how it is calculated. And again, what you do, if you're living on the Sacramento River, you take all the peak flow events on record. And for the Sacramento River, it's actually been monitored for several decades, obviously. And you simply take all those measurements, the highest flow each year, rank them, and use that formula. The lowest event, it might be intuitive, occurs most often. The highest ranked event occurs much less often. And that is what's meant by the 100-year flood. So I want you to know these terms and these concepts, but not the formulas. So I hope that's making sense about recurrence interval and probability and percent chance and sort of what goes into calculating it. There's another little concept here that's a little bit sneaky in a way, in that this method of taking 100 years, the last 100 years, and doing these statistics kind of assumes that the next 100 years are going to be the same as the last 100 years. And so if the climate is changing, some folks are pointing out that this method might not be so valid. But anyway, if you live in this area, you might find yourself on the floodplain. You might find yourself needing insurance if you wanted to live here. And flooding is just one of these parts of our water resources challenge that we have. And that's why I'm introducing these concepts.